Welcome, Earth and Space Science students, to the Chapter 6, Section 1, Landforms Tour of the Earth. So we'll start off here. We have the Earth in full view, and we wanted to, in this section, in Section 1 and Section 2, start understanding the main focus of breaking down the Earth's topography into three basic landforms of mountains, plains, and plateaus. One of the first things we need to do is to understand that elevation changes are into each part of our landforms. So let's take a look at that. And I'm going to add a new tool for you today, which you may have posted when this video posts. And it's called How Far Do You Run? Now, it's a Google Map add-on, and it allows elevation profiles within Google Maps and in Google Earth. So let's take a look at it. So here's the basic tool. It starts up by using your location. And I'm going to show you this tool in advance, but you'll have it within your Google Classroom. Let's take a look at it. Now, one of the first things we're going to do, it comes up is Map View. We're going to go to Satellite View, and you can stop and start this video at any time if you're using this app. It's found under hashtag Chromebook Intelligence. I'm going to go under Satellite View, and our picture here looks like a snowy day in Burgestown. And I'm going to zoom in a little bit to where our high school is here. And what we want to demonstrate with this program, and you may want to use this for hunting or fishing or hiking of the location anywhere on the Earth, you can go to your search tab up here at any time. Now, what you can do, this is a walking path. This is a bike riding route. This is a driving to stay on roads, but we want to do a line. We're going to do a straight line, so I'm going to click on that. And we're going to go from the entrance of the school, zoom down in. I'm going to put that from here, and I'm going to, you see the blue green dot there, and I'm going to plot it just outside the window of the classroom here. And now when we go up to the bottom left, this is where we shows our identification. So zoom in. This will take us to our elevation profile. Click on it, and it creates our elevation profile for every point on the line. So as I move along the grade, it shows me the change in elevation from the green dot to the red dot. You can see it goes and it tells me the height above sea level, my distance of my line. So let's zoom out and let's apply this. And by the way, you have a full point view, and you can zoom out and zoom in, and the same Google Maps functions and Google Earth functions as well. So I'm going to remove that line. So to do that, I come over to the X and I clear the routes, and I'm going to zoom out a little bit. I toggle my elevation profile, and let's just do a larger elevation profile. And I think we can find here, we'll go from Burgestown to Joffrey Bulger. So I'm going to go ahead and grab my line again, and let's do it from the B of Burgestown to Joffrey Bulger. Now we have our line. The distance of this line is 2.57 kilometers. You click on it and put it in kilometers. We'll keep it in miles for right now for our sake. We're going to click on the elevation profile, and now we can see the elevation, or this is a profile view of our topography, our landscape, from starting in Burgestown, lower elevation. You can see now this is probably down at Petrucci's, down this area. You can see the yellow dot or orange dot on the screen. It goes higher elevation going out of Burgestown, goes down, goes up, goes down. So what type of landform do we live on? Now, this is something that we're trying to discuss in this section, and that's what we're going to go focus on. But before we go any farther, we'll come back and revisit this later on, but the landscape that we live on in Burgestown is actually a plateau, an old plateau. And I bet that if we go to any one of these lower areas here, according to our profile map, there would be found a stream or water or a floodplain of some sort. And we'll be discussing that as the year progresses. Now let's go on a larger scale and work to a smaller scale. So let's start here with a map of the United States. And this time I've already pre-drawn a line from California to the east coast of the United States, in the Atlantic Ocean. And I also have another one drawn going vertically or from south to north on a map. And this one, and what is our predictions for the elevation? So let's talk about this one first. What would be your prediction from the elevation profile going from the western United States, in generally speaking, to the eastern United States or the Atlantic Ocean? Let's take a look at it. So now we have our general trend. Now we have overall the western United States is a much higher elevation. Now we have something over here called the Great Basin area. So, and that is actually a lowland between two higher. We have the Sierra Nevada mountains and we have parts of the Rocky Mountains. As we go overall, the western United States is much higher in elevation. And as we leave the western United States into the central United States, it goes lower elevation. And then we have what's called the Central Plains. And then we get to roughly the PA West Virginia border, and we have a uptick in the elevation, or starts moving higher. And then we have another. Now, one thing we can take a look at, which mountain ranges are higher, the western area or the eastern area? Is that determined by age? And that's something we're going to discuss in the future. And it goes down to the coast. So a general trend from the western United States to the eastern United States, elevation decreases. Let's take a look from south to north. What is your prediction of what the elevation does from the southern United States, Louisiana, to the northern United States, Wisconsin, Minnesota? Let's take a look at it. Wow, this is a dramatic change from looking at the western United States to the eastern United States. As we move our line starting in Louisiana, we see a very lowland area. Much of this is just a few feet above sea level. And this is very significant when we talk about tropical storms and hurricanes flooding this region. And we see a small grade up through Mississippi. And then we have another lowland area, very few feet above sea level. 140 feet is not very high in elevation compared to the 1,100 feet that we are at many other places. Now, as we go farther north, the elevation is increasing. We still have that up and down movement as we cross river valleys and erosion over the time of Earth's existence. So we get to northern places, we see it flooding. Now, we will be revisiting this later in the year. We talk about the central United States, and the lower southern United States has been covered by ocean water many times. Actually, 7 to 8 times, in fact. And each of these layers have deposited horizontal sedimentary layers of rock. Let's move on into our Google Earth tour, more specifically to our examples of landforms. Now, if we're looking at landforms, we don't want to be overwhelmed with the entire world at this point. We're going to start locally, and we're going to focus primarily on our North American continent. So let's take a look at it. Let's start our tour. Once again, we're going to start locally, and we'll start near our current location. And when we look around, and this is the shift and mouse button, we want to look at the landscape of our region. Now, overall, from our different perspectives, we see that it's kind of the darker areas are hillsides or valleys, and the flattened areas are cleared. That is, a lot of that's due to man's changing of the surface of the earth. But overall, we see a general trend of flats. Now, the erosion of the streams and over time has affected that, and that's where we get the rolling ups and downs. Now, our elevation is higher We live on a plateau. Let's move on into our first topic, which is, though, plains. We have two types of plains that we've discussed in this section. We have interior plains and coastal plains, and we'll revisit those and take a view tour of a few of those locations in just a few moments. But overall, you can actually see from a map, this is our plains here. The plains cover the interior region. Much of this is what we would call the interior region. And we do separate the plains according to the elevation. We have what's called the high plains out here, high interior plains. We have the central lowlands, which is encompassing quite a few different river basins. And it actually stops where Lake Erie is. I'm just writing the name over top. We have the coastal plains here along the Atlantic coastal plain, and we have the southern coastal plain, Gulf coastal plain, down here at the very bottom of my current map. And on all maps, as we are talking about, north is orientated at the top, south would be at the bottom. So let's go in a little farther into plains, interior and coastal plains. So let's take a look at those. And we're going to our first location away from Burgestown area. And we're going to go to the Great Plains, also known as the High Plains. And if we take a look at this location and go looking around, what do you think this is primarily used for? And looking off into the distance, we can see this is relatively flat, and those squares that you see are actually farming. That is man's effect on the landscape. So this is, overall looks like it's flat. Let's take a look at closer up in depth, and we're going to use our Google Earth guy, click on it, and it'll give you the roads, and we should be able to come down to the local landscape here. And let's take a picture view. Hopefully it zooms us into the correct area. And you can see this is actually the Google Earth camera. If you've ever seen a Google trapping car, it has this big tripod up on the top, and you see its shadow there in the light. So let's take a look at this. But obviously you can see that this is pretty flat land, and we can look around in our image. It is light brush. It is the high plains, which the higher elevations typically are drier. We don't have a lot of dense forest. We have trees and shrubbery, but overall grasslands is what this is focused on. So this is a great example of the high plains of the western United States. Let's take a look at another location and another type of plain. This time you see we're going to the Everglades. We're going to the Everglades National Park. This is a great example of where we have two plains, coastal plains, coming to almost meeting each other. So we have over here, this would be called the Atlantic Coastal Plain, which runs from all the way from northern North America down through all of the states along the East Coast. And we're down here looking, and this is Miami here, and we have Lauderdale. But this on this side, this would be the Gulf Coastal Plain, and they actually interact at southern tips of Key West and throughout Florida. And we have currently hurricanes that are tracking over and flooding these regions, which are great floodplain areas. But let's take a look a little more in depth. Now we have highways called Gator Alley down in this region. Let's go take a look at what a coastal plain actually looks like. And let me get this off the screen here. And here's a picture of the Florida Everglades. And it is often flooded by water, shallow water. And you see the grass, it's so shallow that many times the grasses and the trees rise up and grow up through it. And they are often freshwater mixing with saltwater. So we get different types of habitat for life. Let me close this out. And let's take a look at some pictures. So I'm going to actually go into the main part of the coastal plains of the Atlantic and coastal. And let's put we'll go from a highway view first. And they build the highways up a little higher than the surrounding land so it does not become flooded. So that kind of looks like this area is dry, but when you look off to the right or left of the highway, they've built it up, and this is all dry, wetland that sometimes is wet during the rainy season, and sometimes it's dry. And I chose this because we call this in Florida, if you've ever visited Florida, Alligator Alley, for a reason. And let me jump out of Alligator Alley because there are alligators everywhere. Let's jump down to somewhere a little closer and go back to that location. And let's check out, and we'll go to the coastal plain that I have marked here. Let's take a look at what it looks like. So now from this perspective, this is exactly what a coastal plain looks like. We have flat bottom boats because the water is very shallow. And if you ever get a chance to take a flat bottom airboat ride, that's a great time. Now you can see that water levels go up and down. And this is typical coastal plain. Let's head off to another location in another landform. This time we're going to head to Plateaus. Okay, from our coastal plain, let's head to Plateaus. And the first thing we have about plateaus are raised areas of land, often near higher elevations or the coastline, but they are overall flat. And we discussed this earlier. When they are younger, they are flat, and over time, as they are weathered and eroded, they are broken down. Let's go into a plateau region. And we're going to go probably to the most famous plateau. And even though it is significantly old, it is still flat. So I'm going to zoom in to where we have the Colorado Plateau and the shift key, and let's take a look at our landscape. And overall, it is flat. Now we're actually looking hundreds of miles into the north, and that's where we see mountains off in the distance. And that's one of the beautiful things about living out west. You can see for hundreds of miles and see those mountains in the distance or landforms. Now, this is the Colorado Plateau, and if I can find a location out here in the desert, it is wrinkled in some cases because it is old, but overall, it does not show much weathering because of the lack of rainfall in this region. So let me see if I can find a highway here. We'll get an image. We're on the Arizona border here. And we'll see if we can find a location here. No street view available. We'll find one here in a moment. Okay, so let's find a place here, and we had to travel all the way to the Grand Canyon Visitor Center to find a decent road so we can take a look at what the Colorado Plateau really looks like. And we see, once again, very dry ground, and we'll be doing a tour here very soon. And we have some trees at this location. So I'm going to jump out of this location here. And as we get farther away, you can see the dominant feature here is the Grand Canyon. Now, the Grand Canyon is a river, the Colorado River, that cuts through the entire Colorado Plateau. And we're going to be having a ranger moment video here in one of our next segments here that will describe the formation of the Grand Canyon. Let's take a look at the Grand Canyon Visitor Center. And while we're traveling there, you can see it actually from space. We've mentioned it before. This is the flat of the Grand Canyon. I'm just going to jump to the canyon's edge. We can take our little guy here and go to the point. And let's take a look at really what the Grand Canyon is. It's the flat Colorado Plateau being cut over millions of years by the Colorado River. So we see this is all flat land, layers upon layers of sedimentary rock, and as if I rotate around, has been cut by the rivers and tributaries of the Colorado River. You can zoom around and we can see in the background the steps going up. Let's jump out of here, but let's take another one of the best views in the world, possibly, is this cutting of the Colorado Plateau. So this is a very dry region, the plateau, and the water and the wind over time has eroded this down. We call this down cutting. And we have an acronym in the Ranger moment that you'll watch soon called DUDE, D-U-D-E. It's one of our key things to take away from landforms. So let's head into our next topic from the Colorado Plateau. We'll take a look at our own plateaus. So let me jump to that here in our tour. Whoops, one step too far. And we look at here Western Pennsylvania in point 8 of our tour. And looking at our area, zoom out from this, we can see that this is kind of greenish, way different than the plateau we're looking at the west coast, and that's due to precipitation. But when we zoom in areas here on the western, we see that it looks crinkled, it looks wrinkled, and that is due to the age of our plateau. We live in an old plateau region. See our high school campus off here to the right. Now you see there's trees. These are lower elevations. They are not suitable for farming. In the light green areas, they are suitable. So the trees have been removed, and we have farmed these regions. So if we look, this is entire Western Pennsylvania. Now I'm going to zoom back out for a moment. We're right on the verge between, this is Pennsylvania over here, this is Ohio. Now you can tell by the trees in the landscape as we go farther to the west, and zoom out a little more, that there's more farming out here. This is what we call the central lowlands. They are the plains. As we go from west to the east, we are going on the Allegheny Plateau. So we live on the Allegheny Plateau, and I'm just going to bring this out here and let's describe this for a moment. So the Allegheny Plateau roughly goes right along our border here. Actually, that's a little farther to the east. Here, we have the central lowlands. You can kind of see the change in the color of the landscape. So we're going from the central lowlands to the west, going to the east. This is higher elevation. If I would draw a profile map of this, so this would be low elevation, and this is high elevation. We'll just say this is 1,000 feet. It's not drawn on the scale, but our elevation profile is going up like this to the Allegheny Plateau, and then it's going to go up again to what we have over here in the central part of the United States. We kind of can see just from looking at the trees and vegetation here, there's obviously something that is disturbing that pattern of dark greens and light greens. This is what we will call the Appalachian Plateau, heading to the, right here, these are the Appalachian Mountains. So let's take a look at that in a little more detail. So our next, we're going to be talking about mountains. And we have the plateaus here in Western Pennsylvania, Allegheny Plateau. We specifically live on the Appalachian Plateau, which the Appalachian Plateau is everything here. This is the Appalachian Plateau. We live on a subset of that called the Allegheny Plateau. If you've ever been up to Tionesta, those are the Allegheny National Forests, which are even higher elevation. Let's go to our next topic. And we get into our types of mountains. We have 4 types of mountains: fault block mountains, folded mountains, upwarp mountains, and volcanic. Let's take a look at those. Let's take a look at our mountain ranges. Our first type of mountain range we'll have are folded mountains. Now, once we've already discussed, all layers of sedimentary rock are laid down flat. So they're laid down horizontally. Now, it is the process of inside of the earth where we are being compressed, and this is compression arrows here. That's the force being applied, and it makes them wrinkled up like a rug. Let's take a look a little more depth of our geology. So we look at the North American continent. The Appalachian Mountains extend all the way down, and we can see them. We call them the spine of the Appalachians because it kind of looks like the spine, and that force wrinkles the continent. Now, if we wanted to see the origin of all of this, now this is the Atlantic Coastal Plain right here. This region here is the Atlantic Coastal Plain that are being created by the erosion of the Appalachian Mountains. If you really wanted to trace back the history of the Appalachian Mountains, you actually have to go all the way across the pond, or the Atlantic Ocean, and we see these curvatures of the continent of Africa. That matches up very close because they once were connected to each other to our Appalachian Mountains. You once could walk between the two continents. But we're going to zoom in here to our folded mountains, and just looking, it looks like it's wrinkled paper, and it is because it has been wrinkled up by the forces of time and pressure and tension. So let's take a look at our Appalachian Mountains, and this is the Smoky Mountains, so we went a little farther south than our local Appalachian of Western Pennsylvania. Let's zoom in and see what these mountain types, and that's what we're going to pay close attention to, is the shape of the mountains here compared to all other types of mountains. So as we look out, it looks like we're on the valley floor looking up, and we'll take a peek of a higher elevation here in a moment. And we can see that these are very much like the mountains you may see in central Pennsylvania. They're a little higher in elevation, a little steeper, but overall there are trees covering them. Let's jump out and let's go to a peak. So let's find a higher elevation. And this is a great view of the Smoky Mountains of Tennessee. You can see obviously this is not flat, wrinkled looking, drier at higher elevations, river valleys down below. But this is a great view of the Smoky Mountains, which is actually not smoky. What you're actually seeing is haze due to water in the atmosphere. And this is a great view of an Appalachian or folded mountain type. Let's go to another mountain type. Once again, before we leave, we want to talk about the folded mountains. And there are two terms I want to make sure you're aware of, and those are the anticline or synclines. Anticlines is when the rock folds up. Synclines are when the rock layers fold down. So that is what we have here in Western Pennsylvania and as throughout the eastern United States of anticlines and synclines. And that is caused once again by compressional forces. Let's take a look at another type of mountain type, and those are upwarped. In upwarp mountains, the Earth's crust is pushed up. We can see now this is upward forcing of the Earth's crust. And we're going to go find a tour of some upwarp mountains. And here, once again, we are in the Black Hills of South Dakota. And looking at the landscape, just from looking before, this is light gray, and this is flat land, and this is upwarp. So this entire region, this green region you see here, if I zoom in a little farther, is pushed upwards. You see that wrinkled area. Now, if we take a little closer look at the region, I'm going to zoom in. We can see that this is higher elevation than the land surrounding it. Let's take a look at the Black Hills of South Dakota. And here we have a great view of the Black Hills of South Dakota. You can see that these rocks look like they've just been pushed up out of the earth. And overall, this entire region has been pushed up. And you can see this is a walking trail, and you can see the rocks sticking up. Now, much of the soil along with it was eroded over time, and the hardest rock only remained. So this is the Black Hills of South Dakota, upwarped mountains. Next mountain we're going to be talking about is fault block mountains. Fault block mountains have faults or areas where the horizontal rock layers never match up any longer because one part has moved down with other parts moving up. A fault is any time that a rock cracks and there is movement along those. So you can see the orange layers should have matched up. That should have moved up. And the tan and the darker tan on top with the soil layers. Let's take a look at some fault block mountains and their shape compared to fault block, compared to folded mountains, compared to upwarp mountains. So we're now in the Grand Tetons of Wyoming. And if we take a tour around and look around here, we can see that these are much more of our traditional mountains that many students, many people would say that they have the high snow-capped peaks. Notice they're much higher in elevation, and they are snow-capped throughout much of the year. In the lower, this is actually the high plains that you're looking out, and actually you can see off in the distance the Great Plains. Let's see if we can find a location here at the great top. See a photo here. So you can go to the peak of one of these mountains. Here we've gone to the top of the Grand Teton Mountains, looking off into the high plains. Notice the elevation above the flat plains or the high plains is significant. Looking around in our mountain range, obviously this is from a mountain climber. You can see down the range, pretty awesome view from the top of the Tetons, which I think are one of the most picturesque mountain ranges in the United States, in North America. Let's head next to our volcano section of mountains. This is our last type of mountains. Remember, we have 4 types of mountains: folded mountains, upwarp mountains, fault block mountains, and our last type comes in 3 different versions: volcanic. We have cinder cone, we have shield volcanoes, and we have composites on the left. Let's take a look at these. And our first one we're going to head to is a composite volcano called Mount St. Helens. It's an active stratovolcano, and we actually can break down composite volcanoes into different types as well. In our introductory here, we're just going into the basic 3 types. So we look at a composite volcano. One of the telltale signs of this composite is the damage that is completed. We look at Mount St. Helens, and we look at its peak. We can see at one point it probably was much higher and had a dome that made it symmetrical. But unfortunately, composite volcanoes are extremely explosive, have little lava, and are often destructive in their nature. So let's take a look at those. And we look around, we can see, when we look that it's higher in elevation. You see green area around, and it's snow-capped. It gives you an indication of its elevation. Now I zoom out a little more. Composite volcanic mountains kind of look like, and for lack of a better term, pimples due to volcanic activity that occurs underneath the earth. We can see here is Mount Hood, here is another volcanic mountain. They are snow-capped compared to the surrounding area. They are much higher elevation, and we're going to go to the top of these volcanic mountains, and let's see if I can zoom in here, and we can take a view. Looking around, you can see the previous flows of volcanic ash would create gray areas where no trees or life typically exist. But looking off in our distance, you can see other volcanoes, and I would think that maybe Mount Hood off in the distance. We are on the side of Mount St. Helens that is still remaining. The other side of this mountain blew off going north. You can see the river valleys, but this area is volcanic. Let's head to our next type of volcanic mountain. And we're going to go to a cinder cone mountain in Paracatine, Mexico. And this volcano is famous for being once a farmer's field, and then we have a story of the farmer saw smoke and ash in a crack bubbling out, and over a few weeks and months, we have this volcanic mountain pop virtually out of the soil. The crust of the earth was broken open, and we see this mound. Now, they're very loosely stacked. When we zoom in, we'll see that. But this cinder cone type volcano, you see how it spewed its cinders, small particles of dust and ash, very little lava, outwards in all directions. Let's head in and see if we can get a closer view to a cinder cone volcano. And here we have a view of from the top of Paracatine. You can see, looking around and looking down on the ground, it's made of small particles of rock. Looking down into the volcano's crater, you can see it's loosely made of volcanic cinders. Let's head to our final type of volcanic mountain. We're going to head to the Hawaiian Islands for our final type, which is called a shield volcano. Now, a shield volcano, if we would look at its elevation, is very gentle. The entire area is a volcanic, and the entire area has different vents throughout. There's not a single vent on shields. Many times there's multiple. There's a large amount of lava that's very runny or liquid-like, and actually you can see some of that. And let's see if we can find a location to view here. As we zoom in, you see multiple cones, multiple craters, but overall it's a gently sloping mountain. We're up at the top, above the clouds. See, it's all made of volcanic material. The entire island is a volcano. So these people are all living on an active volcano. And if we look, one thing about shield volcanoes, they often erupt for thousands of years. You can actually see the trail of the movement of the plates as it melted through the Pacific plate, and the hot magma did. And we have the trail of Hawaiian Islands. Many of these islands are back to being underwater or very small islands off of the sea floor. So one of the key things we talk about Mauna Kea is measurement from the ocean floor to its peak makes it possibly one of the largest mountains on the earth. And that's always debatable because much of it is under the water. Okay, so one of the last things we're going to discuss is we divide the earth into these three basic landforms: mountains, plains, and plateaus. We discussed earlier that the western United States is primarily higher elevation than the central United States, and the eastern United States has a very old mountain range called the Appalachians. I hope you've enjoyed this brief tour, and we'll be moving farther into mapping the earth in Chapter 6, Section 2, Viewpoints. Have a great day.